This is Surya Datta. I am a DevOps engineer in SRE squad under CloudOps team at XenonStack. So today my POC topic is on Grafana alerts backup solution and Grafana monitoring tool. Currently I am working on a client project and there I am responsible for setting up and configuring full stack info monitoring stack that can monitor your application as well as infrastructure and can provide a better system level insight with metrics, log and trace. So in this project, we use a well-known tool named Grafana. As a DevOps engineer, usually we prefer Grafana on priority for better visualization of system and application level insights. It helps us to configure alerts. It helps us to escape or avoid disaster or system failures in your infra. Now, here Grafana is deployed on our Azure Kubernetes cluster and it's running as a pod in that cluster. While using the Grafana tool on Kubernetes, I faced some issues like my Grafana dashboard and alerts rules which were configured on with my pod that are getting deleted when my pods are getting crashed or deleted. It was a big headache for us because we have created so many custom dashboards for monitoring and visualization and also configured so many alert rules for these. And alert rules are basically helps us for disaster recovery. And it takes so much effort, so much time to build and configure this. So if every time pod will crash or delete, then how we will store our data, dashboard, configuration, alert rule, etc. if all will delete every time. So and there is no feature like permanently storing this data and permanently persisting this data. So Grafana store this configuration data within the Grafana pod itself only. So in usual scenario, Grafana doesn't have the alert backup feature. We will discuss how to avoid this kind of disaster and how smartly this solution helps us to persist our Grafana configuration, Grafana alerts, notification, rules, etc. Next, I will discuss how I am able to persist this data. So now I will discuss about solution. So after a lot of research, we have found some solution. So I will describe you these solutions on a visual diagram with this configuration. Here I will discuss you the steps which I followed. So in the first step, we need to change the Grafana pod's configuration file. In another word, we need to pass or implement some extra parameters in Grafana config map, which is stored in our Kubernetes cluster, to achieve this backup solution. Secondly, always use persistent volume with Grafana pod and mount it with that pod. PV means persistent volume. It will attach with your pod and it will provide you the long-term support, long-term storage. After changing the configuration and saving it into the Grafana config map, you need to scale down the Grafana deployment or you can restart the pod for saving the configuration. That's it. Now, our configuration saved in the Grafana pod. We will give you more details in this. Here I want to describe a bit more that it will give you the persistent or it will help you to save your alert rule forever. In the future, if your Grafana pod might be crashed or it will be deleted by somehow, it will save you from data loss. So before jump into the implementation part, I want to show you some architecture diagram of Grafana. Here, as you can see the screen, this is the architecture of Grafana. This is our Grafana running on Azure Kubernetes cluster. So it has some different components with their different working principles. So This is Agar or Open Telemetry tool, which is collect your traces from the application. So it comes to the distributor and then it ingests by Grafana's own ingester component, and then it's go to the querier and querier sends it to the query frontend, and then we visualize our Grafana. Similarly, we have also our matrices from our system levels inside. Here the matrix backend sends the data to matrix generator and sends it to the ingester, and similarly it comes to the Grafana dashboard. Here is compactor. So all the matrix logs and traces will store in our storage. Here you can see we can use the S3, which is on AWS, GCS for Google services, and Azure for Azure. So here we have used the persistent volume for our Kubernetes cluster. This is the Grafana architecture. Now let's look into those easy implementation steps technically. There are tons of solutions, but after did some research, I have made it possible for this problem. Here you can see the architecture diagram. So Grafana